hint or where this formula and how this formula is identical, actually exactly related to this formula of mr is equal to mc. I'm not going to give you all the derivations, but I'll give you enough so that you can actually do it for yourself, okay? So let's express this in a graphical way first. So mr is equal to mc. Okay, let's do this graphically. If you go back to your pre-sessional courses videos, for example, you will remember that if you have a demand function, P, Q, it goes down like this. Okay, we can be very general here and say P is equal to A minus B times Q. Where's the A going to be? The P-intercept, okay? Right? So when Q is equal to 0, that's what will be, okay? What would be the Q-intercept? What would be the Q-intercept? A divided by B, always, okay? So if you want to kind of memorize them, you can memorize those things so you can very quickly draw those lines, okay? And find those lines over there. Anyone remembers from the pre-sessional course what the marginal revenue looks like?
Just the half of
it. It starts at the same point, but it has twice the slope. So the slope is twice as steep, right? Which means that this point here is going to be A over B times a half. Agree? Or in other words, the marginal revenue line, if I do it in purple, marginal revenue as a function of Q will equal to A, YA, because it has the same y-intercept, but the slope should be double. So minus 2B times Q. Everybody's with me? Everybody's with me. Okay. Now, and you know that marginal cost generally would be, in this course, almost always, actually always, will be equal to a constant number, like C, for example. Okay? Like 5 or 1.5, as you had in the problem set. Now, the bits that you should realize is that what is another way that you can represent the slope of the line? Anyone remembers from the pre-sessional, what was the slope of the line? The slope of the line was you could take any 2 points of the line and then do what? Lauren, what could you do? What was the slope of the line? Is the derivative of it? Yeah, sure. But what's another way that you could see the slope? The tangent, which is the actual line. What is the slope telling, NJ?
Wasn't it? I'm not sure. When you subtract the two, it's the
Yeah.
increment?
Yeah, the increment. Something to do with the increment. Yeah, that's fine. Lun Chao, do you remember? No? Ricardo?
For every change in Q, one change in Q, there's some in P.
Yeah, for some change in Q, if I go from point A to point B, this slope, which is the B here, the slope would be from this point B to this point A, there's going to be a change in price, agree? Let's associate that change in price with that height, okay? And there's going to be a change in quantity. Let's associate the change in quantity with this other height here, with this other distance here, delta Q. What's going to be the slope? Is going to be the ratio between delta P over delta Q, always. So in other words, instead of writing marginal revenue as a function of Q, which is equal to A minus 2BQ, I could instead write delta P over delta Q. Agree?
And that is the price elasticity.
No, that's not the price elasticity, but it is part of that price elasticity, right? So you can start to see some of the resemblance on it. I'm not there yet, right? So the moment you write the marginal revenue to look this way, you are roughly in business. Now, we only looked at this bit here. Now let's look at this bit here. The left-hand side is easy. It's just price minus marginal cost over price. There isn't really much I can do about this. But what about the right-hand side? Anyone can tell me what is the elasticity formula? If you don't remember this, look at the video on elasticity. I do a very sort of like slow derivation on what elasticity is. But this elasticity is going to be delta Q over delta P times
P over Q.
P over Q. Well, you're starting to look at the similarities of this because this bit here is starting to look like this bit here. Okay? Now, how can you convince yourself that this bit here is the same as this bit here? Well, in maths, the way you convince yourself that way, if you want to show that they are identical, you should be able to start from this condition and go to this condition. And you should be able to start from this condition and go to this condition. Okay? Let me try and attempt to do it. Maybe give you the first sort of like beginning on how you can go about it. And I can give it to you sort of like as a homework to try and figure that out, if possible. Go through the lecture notes with Ignacio and try to grapple with that concept a little bit more. And then you can try and figure it out. But here's the idea. Marginal revenue is simply going to be A minus 2 delta P over delta Q times Q is equal to marginal cost. Agree? This bit here is your marginal revenue. This bit here is your marginal cost. Okay? Okay, I want this to manipulate this so that it looks something like P minus MC over P is equal to 1 over the absolute value of E. That's what I want, right? Or, I don't have to think of this as absolute value. I could remove the absolute value. From the video that I've done on elasticity, you know this is always a negative thing, so I can just do minus E. That would be equivalent on just writing minus E there, because E is always a negative value, as I will show as I've shown in that video. Okay, so do I have anything that looks like the elasticity here? Do I have anything that looks like the elasticity? No. Aunt Sophie?
Oh no, I was just looking at the elasticity formula.
If you look at the elasticity formula, does anything that I have look like the elasticity formula? Yeah. Okay. The deltas are there, okay, but they're a little bit over.
Can't you just switch it around? Because if you multiply, for example, how do you call it? The one with the two denominator, nominator, you can switch it around to like divide.
You can switch around, but here's what I can do. Is anything that prevents me to multiply both sides of this equation by P? Can I do that? I can, right? There's nothing that prevents me to do that. Okay, fine. So then I'll have A times P minus 2 delta P delta Q. Sorry, I didn't want to multiply them by P. I actually wanted to divide them by P. 1 over P, 1 over P. A over P minus Q over P is equal to MC over P. Is this starting to look a little bit closer to the where we're trying to go? Well, a little bit. Why a little bit? Because this bit here is what? 1 over the elasticity. This bit here is 1 over the elasticity. Agree? That's the formula of the elasticity, right? If I take this and I do 1 over the elasticity, I'll have 1 divided by delta Q times P over delta P times Q. Go to the rules of how to deal with this inversion. It's the same thing as flipping them. So delta Q times delta P times Q over delta Q times P. Right? You can flip those sides. So I'm just using the rule 1 over A over B is the same thing as B over A. So I can flip the numerator and the denominator. So all of a sudden, you're starting to see things that are starting to look familiar. Okay? Things that are starting to look familiar. And what you need to kind of go on from here is rearrange this in such a way that on this left-hand side, you really want to have P minus MC, right? That's really what you want to have over P. And here, you just want to have this left over. So this bit here, if I take this bit here, without the 2, what is this? This is the same thing as 1 over the absolute value of E. Okay, without that 2. So I'll stop here because I don't want to sort of spoil the lecture as well, right? In some sense, and we can go back to this again. But you can get a sense that by coming from this marginal revenue is equal to marginal cost idea, you could rearrange enough of this stuff to try and get to the inverse elasticity pricing rule, which Ignacio has not yet finished, right? So here we're in week 2. He's not yet finished that, but I'm sure he'll finish that on Thursday. Okay. So I'll stop this here. I'll let you discuss it for a minute or two, and then I'll